Hi everyone, and welcome to my workshop. Today I'm going to talk about one of the robots I'm working on. Roz, as you can see from the picture, is a quadruped walking robot. Roz has 3 degrees of freedom in each leg. 3 degrees of freedom means that each leg has 3 servos. 1, 2, and 3. Roz also has 2 servos in the tail, which hopefully will help with balance, and 2 servos on the neck. That's a grand total of 16 servos for the entire robot. Roz uses Bioloid AX12 servos from Robotis in the Dynamexel family. They're powered from 12 volts, and each servo has its own microcontroller board inside. If you look at the back of the open servo that I have here, the chip on the board is an Atmel ATmega 8 microcontroller. Each servo is basically a device on the servo bus with its own ID. You can see this servo has the ID of 8, although you can change that with software. All devices on the bus share the same communication wire. Each servo has 2 jacks, so they can be daisy-chained together. Each jack has 3 wires, one that holds 12 volts, one for ground, and one for communications. Roz uses a USB to AX interface board to talk to servos and other devices on the servo bus. Roz is controlled by a Raspberry Pi Zero-W. The Raspberry Pi talks to the servos over a USB serial port. If you look at the robot, you can see the USB cable and then the USB to AX board that I showed earlier, which is connected to the servo bus. Roz walks using inverse kinematics. I'm not going to spend a lot of time talking about IK because there's lots of good resources out there that talk about it at length. In an inverse kinematics robot, the gait is what drives all the movement. The gait basically determines where the feet will move to at any given time. This is the old gate system. It determines 4 different locations for each foot, and Nuke interpolates between those 4 points to make it smooth. While the foot is on the ground, it pushes back, which makes the robot move forwards. This is my new gate system. It pre-calculates all the points along the walk cycle and uses inverse kinematics for each frame rather than interpolating between keyframes. This really only works because we're running on a powerful CPU, the Raspberry Pi Zero, and not a small embedded microcontroller. Most of Roz's sensors are packed into the head. Roz has 5 range sensors, a 9-axis IMU, a down-facing optical flow sensor, and a camera. Roz has 5 fixed Lidar sensors, the VL53L1X time-of-flight laser range sensor from Polalu. They are placed such that they're at 45 degrees to each other, so there's one pointing straight left, one pointing to the front left, one pointing front, one pointing front right, and the last one pointing to the right. Roz also has an onboard 9-axis inertial measurement unit, or IMU, which has its own onboard processor to handle running a filter for the IMU data. This IMU is also on the I2C bus, the same I2C bus that the rangefinder sensors are on. Roz has an optical flow sensor board, which works something like an optical mouse, except it works at much further distances from the surface. It is controlled over an SPI interface, and it's a down-facing sensor on the bottom of the head. Finally, Roz has a camera, which is connected to the Raspberry Pi Zero over the camera interface. With the exception of the camera, all of the aforementioned sensors are controlled by this ARM Cortex-M4 board running MicroPython. In addition to talking to the sensors, this board is also a device on the main servo bus, so the Raspberry Pi Zero can talk to it in exactly the same fashion it talks to the servos, and thus it can access all of the sensor values. This board is powered off the bus through a very small switching voltage regulator, which you can see in the picture just below the blue board. This is a custom board that my brother and I designed and I built that controls power to the robot. It has a Cortex-M4 chip on it running MicroPython, and it allows me to power up Roz with a momentary push button, like you do with most modern consumer electronics. You push and hold the power button for more than a half a second to power up Roz. And now it's powered up. The power board also includes a servo bus distribution strip, an RGB LED, which is next to the power button, and it provides power to the Raspberry Pi Zero through a Palalu 5-volt 5-amp switching regulator. The other thing the power board allows me to do is automatically switch between battery power and wall power when I plug in a wall power plug. This guy right here. It isolates the battery and switches immediately to providing power from the wall socket when it's plugged in. When the wall power is removed, it switches seamlessly back to providing power from the battery with no interruption in power and no need to reboot the Raspberry Pi.